What is this? Whatever could it be? Oh my gosh. I knew it was coming! Yes. Are we recording? Yes! Welcome back to another team video! I have no idea where we left off, so I'm gonna jump back into our Udacity notes. It was somewhere in the middle of state management, and we're gonna pick it up from there. Alright, I found where we left off. At the end of the last video, we were just about to complete the controlled component exercises. So there's two of them. They're a little bit bigger, a little bit more time consuming than previous exercises. I really enjoyed them both, however. As we did go over in the previous video, what a controlled component does, what it is it's basically the term you use for a React component that manages form state. Normally, form state is managed by the DOM, but because React is so talented and skilled at managing state, when using React, we want to use React components to manage our form state. So that's what we practiced in these two exercises, which were very awesome. Completed those. You can see them on GitHub if you want. I'm going to actually reread what they were here briefly for my own curiosity. It was a while ago. Alright, moving on from that. Then we go to the final lesson of React State Management. I'm so happy to be at the end of this module. This module was a very long one, and as it should be. We're managing state in React. That's basically the main awesomeness of React. It took a long time to get through this freaking module. But we get to the lesson challenge. I did read these 5 articles. There's a lot of extracurricular reading throughout the course, but whenever we come to a lesson challenge, whenever I've come to a lesson challenge throughout the course, it'll give you some articles to read in order to specifically help you answer these questions. So, what is the difference between stateless functional components and class components? A class component is a JavaScript class or React component that extends react.component or is created via react.createClass. A stateless functional component is a JavaScript function used as a React component which does not manage state. Currently, stateless functional components are the only type of functional components available to React devs. Functional components capable of managing state are in the works. Okay, yeah, so I remember reading about this. There is something to be said for keeping your terms when referring to different types of components. Keep your terms very specific, because you have class components, which is like you create a class that extends React component, or you just go right ahead and call react.createClass, and that's a class component. Otherwise, you can have functional components. Right now, which is just a JavaScript function. You just write a JavaScript function. If you want to pass in props, you can, but it does not, a JavaScript functional component does not manage any state currently, which is why the current functional components available should be referred to as stateless functional components, because what the React devs and the people who manage the React library, I guess that's Facebook, are working on right now are functional components which are capable of managing state. So you want to keep your terms really clear. Right now we have stateless functional components available to us and class components. So just bear that in mind. Describe the reasoning behind controlled components. So this is what we were just talking about at the beginning of the video. One of React's primary strengths is managing state, the internal state of your application. Typically, forms have their state managed by the DOM. With controlled components, React devs can render forms that have their source of truth living inside and managed by the controlled components state. Yes, so in React, you have the components. Components can have state. You want your forms rendered by a React component to also have their state managed by that React component. Just let React manage the state of your forms. So that 1, the DOM doesn't have to do it, and 2, React is talented at that. That is like one of its primary strengths. There you go. Probably copied that from some article I read. But that is exactly true. What is the correct way to modify state? Make sure to explain what role a child component like add user can have in the app. So I'm not going to read the answer yet off the top of my head. You always modify state with set state, the set state function. I have not come across anyone saying do it another way. Maybe there are extreme examples. If they are, as a beginner, I have not learned them. always modify your state with set state. React will know to automatically compare and re-render components to see if anything has to be re-rendered to the user now that the state has changed, if you modify your state with the set state method. So make sure to explain what role a child component like add user. You always want the owner of the state to set the state, to manage the state. So what a child component, let's say you have a parent up here that owns the state and you have some children components, what a child component can do is receive the information, maybe user input, that is going to affect the state. What the child component does is pass that information up until that information gets to the owner of the state, and then the owner of the state will actually call set state and update its own state. You don't ever want to, I'm not even sure like how you would architecture or code a child managing a parent's state. Or maybe there's some way you can like pass some funky values up to do that like incorrectly. Don't do that. Just pass up whatever information you need to determine the state and then let the owner manage its own state. Always do that. The owner, the parent, whatever. And then the parent will obviously pass that state down through props back to the children who need to see it. Alright, so we talked about that. Lesson exercise. This was the all-together exercises. Biggest two exercises so far. We had the controlled components, which were big, and then these were even bigger. Create a simple video game community website which adds new users and displays the user list. That was a ton of fun, and I will show that to you right now. Give me one moment. Okay, so I pulled up this project because I just think it's so cool. I wanted to show you guys. We're supposed to make a simple video game website. I believe the main point was you're supposed to add a first, last name, username, and then it'll display as soon as you sign on or add the teammate, but you know I said sign on because it's cooler. It'll appear here, and then automatically it will add a number of games played, and then you can use this little toggle to hide or show them. That was one of the requirements for the app. So let's do this thing real fast. Talima, Veil, username, team Talima. You can hit enter to sign on, and there we are. We are on our teammate list, and it's so cool, and I really like it, and it makes me happy. And then if you want, you can toggle this yes or no. Now you can't sign on with the same username, so you have to program that. You can change it, and then you can sign on. And then if you do this, it'll let you know it's already been taken. And then you can sign on, and it'll hide the games, or it'll show them, and it's super awesome. So, took me a while, did a little bit of styling just to, I don't know, have our colors and make it look cool, and change the header around a little bit. I don't know freaking why, but it took me longer than I should have spent to get the CSS for this little thing to appear in the upper left-hand corner instead of like in the center of the header, which it normally is. Normally they do the header for you, and normally it is what it is. But I changed it because I wanted to. So, that's that project, and it was awesome. The next project, add interactivity to a static local chat room simulation template. Yeah, let's pull that one up too real fast. One more second. Alright, we're still recording, so here we are. This is, I didn't do as much styling on this because I was trying to get through the exercises by this point, but what you can do, what I added is you can choose your own username. So originally this was not part of the project, but I wanted to, you know, be Talima because that's awesome. So you can log in, and now I'm Talima, and then you can write, if you can type properly, are you there? Send your message. Your messages appear in green, just to let you know. And then let's say I'm talking to, if I can type properly, Shadow. So Shadow can see my message. Look at that. It's awesome. It's awesome! It's super cool! Can you send messages if there's nothing here? No, you cannot. That's excellent. And then it doesn't scroll. It just gets longer and longer. But again, I already spent time doing the username thing, so I wasn't going to spend more time on like CSS. I suppose I could change that with a simple overflow though. Maybe we'll add that later on. Probably not. Later on. I'm done with this exercise. So those two were both very cool, and I enjoyed them very much. We finally finished state management. I'm very glad to be at this point. I wanted to, you know, put this video up and share this point with you guys 2 weeks ago, and then I missed a video, and then Thanksgiving happened and I missed another video, and now we're here. We're here, it's amazing, and I have to stream later tonight, so excellent. But we're doing this video now because I have stuff to show you. Because then we move on, I put the course like back backwards on top of itself. This is 2.2. We just got through 2.3, so now I have to actually go up to find 2.4. Hang on. There we go. Lifecycle events. This was very short and sweet. There was no exercises. So we'll go over the information, hopefully quickly. I do have a tendency to ramble. You know this about me. But hopefully quickly. And yeah, we'll get through this. So we learned about lifecycle events. We never, ever, ever want to fetch data of any kind in the render method. So every component must have a render method. That is the only method it must have, because that is what a component does. It renders something. So that's all you need. But usually, I don't know about usually, but often you're going to want data to render. You're going to want to render a specific piece of data. Don't fetch it in the render method. That's what lifecycle events are for. So lifecycle events are specially named methods in a component. They are automatically bound to the component instance. The most common lifecycle events that we'll be using, that any React developer uses, is component did mount, invoked after component is inserted in the DOM, component will mount. Okay, so I had to check on something because I wasn't sure if one of these listed lifecycle events was actually one that has been recently removed, or like support for it in React is actually being removed. There was actually some course notes on it, but I just had a typo. So we have component did mount, component will unmount, which is invoked before the component is removed from the DOM, and then get derived state from props. Invoked, another typo, after component is instantiated when it receives new props. So these are very common lifecycle events, which we'll be using. Hook into different parts of the lifecycle of React components. That's what they do. It hooks into different parts, different moments of the lifecycle of a React component. Should component update true by default? So we have this. There's some extra reading. I know I did some of the extra reading. Most of the extra reading I like skim through, and if I'm really interested, I'll finish it. It also depends on how much time I have at that moment. So moving on to the next lesson, component did mount should be used to fetch remote data in AJAX requests. Use component did mount. That is a very popular one. So I believe the reason for that is like if you're adding something to the DOM, you're going to wait until basically like the HTML, until the element is on the DOM, that's rendered, and now you're going to fill it with the rest of the data. So maybe that means you're going to be changing. Still learning exactly how lifecycle events work, but let's say you're going to be updating a piece of state. There you go. Setting state in this method triggers re-rendering. So if you are waiting for a request to come in, then you can use the data from that request to set state, and when you set it, it will trigger the re-rendering of your element. So the user will first see like the shell, maybe like some nicely styled, I don't know, text paragraph border thing, and then as soon as the request comes in, the state will, setting the state will trigger the re-rendering of the component, so the next thing the user sees is that box and then the text appears. So it kind of shows that you load as much of the page as you can as soon as possible. That's kind of where my brain went with it. If that's not exactly what I'm supposed to be thinking of, then there you go. But that's, I think, what is happening, because you're waiting until the component has mounted before you fetch the remote data you need. And then that triggers the re-rendering automatically when you set the state. Component did mount is one of many lifecycle events that React offers. Component did mount is called after the component is mounted, rendered. Dynamically fetch data or run an AJAX request in component did mount. There you go. Lesson challenge. Already to the end of this module. Why? Because this is not the module called state management. Not that module. That's why. That's what's up here. It's very good. Very good. Already to the end of the lesson. Lifecycle events are methods that hook into points in a component's life to run some of our own code. We use these methods to run some of our own code at different points in the component's life. 3 categories of lifecycle events. Adding to the DOM, you have the constructor, you have get derived state from props, you have render, and you have component did mount. For re-rendering, get derived state from props, should a component update, render, get snapshot before update, component did update. Removing from the DOM, component will unmount. So those are the 3 categories of lifecycle events. That is what's going to happen to your component. It's either being generated for the first time, it's re-rendering itself, or it's being removed. That's what you got. Lesson challenge. Describe what the code in the app.js file in the workspace below will render on the screen and explain why. Okay, so this was, they gave you a piece of code. I had to read through it all, understand all of it. I even tested it to figure out exactly what would happen. And this is what we came up with. The code presented exports the app class, which renders a div composed of 5 other React components. The 5 components are each coded in a different style. So that's like we had like a class component, we had like a stateless functional component, and more. They were all written a little bit differently, each component. Yet each renders a bold text title and the current date in seconds as a string. The app, so it was counting from 0 to 60 is what was happening. The app class sets its state. Its state was only one bool, which was equal to true at an interval of 1 second. So every second, the app class's state changes, is reset, which is passed as a prop to the 5 components, causing them to re-render. The exception is the first component, which does not re-render due to its nature as a pure component. I had to read up on pure components because I do not remember covering this in class, but what a pure component in this case, the difference it had between all the other components and our pure component is it did not cause a re-render when we passed the one piece of state, that boolean, which equaled true. All we did each second was pass that same boolean with that same value, true. So because it was, even though we're passing new state or we're passing information to the pure component, because the state is not changing, a pure component only does a shallow comparison against its current state, is I believe how the docs described it. So it did not notice or register the change, so it did not re-render itself. So we did not see the second, the countdown timer we had from the other 4 components. We did not see that re-render in the pure component. The pure components implements should component update with a shallow props and state comparison. There you go, a shallow props and state comparison. Our pure component does not think it should re-render since its one prop value, the bool, never changes from true. So there you go. There you go. Describe a React anti-pattern that's used in the code. The code was not written well because 4 of the 5 components rendered through app initialize their state with props. Don't ever initialize your state with props. Don't do that. React developers should never initialize state with props because even if the props change, the component will not re-render. Components only know to re-render after setState method is called. Modify the normal3 component, that was one of our components class names, in order to keep it from re-rendering, and I set normal3 to extend react.pure component rather than react.component. Maybe there was a different way they were going for, because like I said, we didn't cover pure components in the class, but that was the easiest. It's literally 4 characters, so I just typed that in and it did not re-render, so it was great. And that was the end of that lesson. So 2.3, 2.4, now we're on to 2.5. This was new and I got through all of it smoothly until the very end, until the lesson challenge, and that gave me a bit of trouble. So let's go over that now. Alright, React 2.5, React Router. Single page applications can work in different ways. This was so great to get to because I have asked some friends of mine and done some research about what makes a single page application different from a regular website and a web app different from a website and yada yada yada. So we learned a little bit more about that in this one, which was really cool. Single page applications can work in different ways. Download an entire site's content at once, or asynchronous JavaScript requests are made for the next data page requested. Good single-page apps use the URL to control the page content. Bookmarkability, we went over this a lot. That was by far the biggest reason. You don't want your users to bookmark, I don't know, teamtalima.com after they've been on teamtalima.com, they've clicked 5 links and scrolled down to, I don't know, their favorite paragraph. Like, you want to have as specific a URL as possible so that the user can get back to that exact state, the exact state of your web application that they're interested in. In order to do that, you don't want to be controlling your page content through the state of your application, but through the URL of your application, which is why we like React Router, because React Router can do just that. React Router turns React projects into single-page applications. Beautiful. React Router is a collection of navigational components that compose, even more beautiful, declaratively with your application. 2.5.2. short circuit evaluation, expression, okay, so this was, I know there was some lessons in here, this must be the one where there wasn't a lot of new information. We did go through and use some things in the course project. It's like a contacts app project, and I have not been including that in my notes because it's just like examples they want you to go through, but it's not the official exercises. So what I did learn new from this lesson, though, was the syntax for the and expression, the short circuit evaluation. You can read more about it here. If first expression evaluates to true, then you're going to run the second expression. If the first expression evaluates to false, then you're going to skip the second expression. And what you can do is you can wrap the second expression in parentheses and then have multi-lines of stuff. So basically, if your URL equals this specifically, like if URL equals this, then that's going to be true, and then you can run or render whatever code you're interested in rendering if the user is at that specific URL. If the URL does not equal whatever, if it's false, then you're not going to render this set of components or this set of data. That's how we were using it. So 2.5.3 in React Router, everything is just a component. When using browser router, you render a router and pass it a history prop. History comes from the history library, also built by React Training. I believe React Training are the people who built React Router. For React Router to work properly, wrap your whole app in browser router. You do have to do that. Browser router wraps the history library, makes it possible for your app to be made aware of changes in the URL. I don't know much about the history library. I want to learn more about it, but it's exactly what it said. It makes it possible for our application to be made aware of changes in the user's URL. So, 2.5.4. Why is there not a space here? There should be a space here, and it should be a little bit bigger. There you go. The link component. There you go. The link component is the way to provide declarative, accessible navigation, period. So we were using link and we were using route. Those are the two most common components we used in React Router. You do have to wrap the application in browser router, but then you never touch that again. The link component is the way to provide declarative, accessible navigation. You pass the to property to tell your app which path to route. The to property can be passed a string or an object. So an example of an object would look like path name / courses, search with the sort name, hash, the hash, state, from dashboard, true. React Router, I did not use all of this stuff. So we just used strings. So let's keep reading to go on. But basically, if somebody clicks on a link component, it will update your URL to go to that path. React Router provides the link component. You can expect link to behave how a normal link on the web behaves. Good, yes. So throughout the course, it's making the point that a normal link, whenever you click on like a normal href link, whatever, hyperlink on the web, you have the ability to hit the back button and go back. If you do that, you have the ability to go forward. You have the ability to bookmark wherever that link took you. There are certain capabilities that go into links on the web that they possess that we kind of just take for granted in certain ways. We just don't think about it. It's like, oh, we were looking at this content, now we're looking at this content. We do that a specific way. Single page applications can show you different content without following those same steps, so then you lose certain features that users of the users of the internet, users of web browsers have come to expect. So link behaves how a normal link on the web behaves. It gives you all those features back. So we definitely like link. Link is excellent. And it is a part of React Router. The route component takes a path that will match the URL or not. If the path matches the URL, route renders that UI. Route does not check state, it checks the URL. Route checks the URL. So this is the part where we, instead of checking state, we're now checking the URL, which is like the first thing we talked about. So this is good. To pass props to a component rendered by route, use the render property. To have route render a component for you, use the component property. So those are two different things. If you want to pass props to a component which you're rendering through route by route, you're going to use the render property. You're going to use the render property on the route component. If you want to just have route render a component for you, you're not passing it anything. Let's say it's just a display component or just a static component. then route can render it for you, can create the component for you, and then you would pass it the component property. So the render property and the component property are different. Component is the simplified, create a static component of whatever you give it. Render is if you want to pass your component anything, manually create it and pass it stuff. Route is a critical component of React Router, yes. It decides which components are rendered based on the URL path. That's exactly what it does. Based on your URL path, it will determine which component is rendered. Usually it's like which component sections, like which path are you going to go down? Are you going to show this to the user or are you going to show this? Well, that depends on what link the user has clicked, because the link will change your URL to either equal this or it will change your URL to either equal this, depending on what the user, the viewer, the player, whatever kind of application you're building, has clicked on. So if it clicks link 1, the path now equals 1, then the route, which equals 1, is going to render all of its stuff. The route which equals 2 isn't going to do anything. So that's how it works. It's very cool. 2.5.6, build out contacts app. We did that. Default form behavior serializes values from input as query string to the URL. Default form is serial value from input. Oh, yes. So default forms, just regular form behavior on the web, will serialize values from input as a query string to the URL. We don't want our URL to be updated by our forms. We're going to use the form serialize package to serialize input as a JavaScript object. We're going to pass that JavaScript object as an argument to the parent's callback prop. Parent, the app, saves object as a new contact. Yes, that is what we did. So when we input a new contact info into our form, we don't want it to go into a URL. We want it to go into our database. So we serialized it as a JavaScript object, passed it back up to the parent, because our form was a child component. So we passed it back up to the parent component, and then the parent component saved it in our database for us, which was awesome. 2.5.7 lesson challenge. So this is the part that actually tripped me up a little bit. It was just tricky to get through. When user clicks a link, React Router transitions screen and updates the URL. So when a user clicks a link, React Router transitions the screen and updates URL. The back button works, forward buttons work, refresh works, and the new tab button works. So those are features I totally forgot. All those things will work. Lesson reading, we have this one, which we were going to read. They had a lot of extra reading, I believe, for this chapter. Yes, so a lot of extra reading. I did include all of it. Some of these are just people to follow in the React community. I almost didn't include it, but then I thought maybe you guys are really interested in following some of these people. So here's the list. It will all be in the external links as well, so you can check those out if you want to. And then we have our lesson challenge. We did the reading. What is the difference between link and route? They're not the same at all. Link provides a declarative, accessible navigation around your app. It will move your URL. It will move the user somewhere else. Route renders UI when a location matches its path. So when our location, wherever link has moved us to, if our location matches a route's path, then that route will render its UI. Will render the UI that it's in charge of, that it's monitoring, that it has, however you want to say that. What is the difference between, so link moves us around and then route actually does render stuff depending on where we are. Excellent. What is the difference between match.path and match.url? Give a use case for each. They are very different. Match.path is for nested routes. The path pattern used to match, useful for nested routes. So this is what match.path looks like. That is what routes use. Routes use a path. Match.url, the matched portion of the URL, useful for nested links. Links will use match.url. Match is, hopefully I'm saying this right, match, by the way, since it didn't come up anywhere else in my notes, is a prop or something, a set of data that gets created, I think it's by a route component, but definitely by React Router itself, and you can use it to access things like the current path or the current URL. Or there's some way to access history, there's some way to access location. I think it's all through match. I might be getting my props mixed up, my props and my properties mixed up. But I think that's all through match. Number 3 is create a code example where you 1, pass props to a component that's rendered by React Router, and 2, use nested routes. Okay, so this one took me longer than it should have. Create a code example where you, 1, pass props to a component that's rendered by React Router. That one's easy. So that's the difference before, like we were talking about, where was it? Right here. When you create a route component, you can include a render property or you can include a component property. If you include a render property, then you can pass props to whatever components you are rendering. If you use the component property, you're only passing the component. So it would have to be like some kind of display or static component that didn't require any additional information from the developer, or at least not in that case. So what we're going to do to pass props is we're going to use the render component. This code is very small, but let me figure out here what we're going to do. So right here we're doing render equals, and then we have our good thing right here. So all of this is a render component. You can see the ending tag right here. And then within the render property, we have this. So using the render property, are we passing in props? It doesn't look like we're passing in props. Why am I not passing in any props to render? I don't know, man, but you could have passed props right here. And then what's going to happen is when we are at path example ID, so we're at example, it'll be the example 1 or example 2, either one. We're going to have an option to link to, we're going to match the URL. So this is a link now, right? A link component. So instead of using path, which is what router uses, and we're not trying to match path, we're trying to match the URL. So for link, we're going to go to a URL, code 1 or code 2. So this is what the text you can click on, example code 1 or example code 2. Once we click that, our URL will change. It will be whatever, localhost 3000 / example 1 / code 1 or 2, depending on what we click on. And then route doesn't care what our code ID is. It's just going to take code ID. So we're going to use path because we're back to a route component. So path will equal match.path code 1 or 2. And it will, in this case, we didn't do a render. We just did a component. And that will display code. And all code does is links to a home page. No code here, time to go home. So our code component just links back to home. So very cool. So that's an example of a nested route. We went from app to example to code. We did it across 3 different components: app, the routes to example, and then example routes to code, and then code links back to home. So there you go. And then if you go home, you'll notice that we're right here, we're routing to just the home. And this is what we get when we're just at home. But this is an example of nested routes. And then I can't believe I actually don't, in this copied code, I actually don't pass any props in. But this is how you would do it if you were going to pass props in. So there you have it. There you have it. Congrats and keep learning. So we have finally made it through the end of Module 2. We made it through all the lessons. Lessons 2.5 was the last one. More to read if you want to. And now the next thing we're working on is our first main project. It is project number 1. And it is called My Reads. It is a book tracking app. We're going to have 3 shelves. One is want to read, one is currently reading, and one is has read. I don't know if that's the order they're in, but those are the 3 shelves we're going to have. So I am learning about that. I've already read about it a little bit. We have set up that project, and we're about to design it, like plan out our React application, and then we'll actually get into the code. So I'm very excited to finally be at this stage. Thank you for watching this slightly rushed video. I owed it to you guys. I just had to get it done. And hopefully I remembered enough to make it a reasonably fun read and reasonably educational. I forgot to go over my extracurricular reading. If you want, you guys can read this off my screen really fast. They're kind of notes I didn't plan for the video, I just made for myself, but I found them really useful. There was a few other articles that were good, so please check out the links below the video. If you want to stay tuned with what we're going to be working on next, please like and subscribe and turn the notifications on. We will be streaming every Tuesday. Tuesday stream days. I would say Friday is our video day, but this video is not going up on Fridays, so feel free to check out on Fridays. Eventually, I will get it right, but for now, I'll keep focusing on streaming as my top priority, and I will see you guys soon. Thank you so much for keep it in touch. Hope you enjoyed the 2 projects. And if you want to see more of them, you can check out our GitHub. All of my React projects or exercises are posted there. As soon as I am done with this first project, I will be there in its own separate repository as well. So see you soon, team. Peace out and have a good one. Bye!